so there's port, there's Rosarito. He travels 15 miles on a course of 100 degrees. Now remember, what is due north? Degree-wise? 0. East is 90. So wouldn't a course of 100 degrees look kind of like this? Does that make sense to everybody? And he travels 15 miles, so the length of that is 15. Yeah. So now the ship started here, now the ship is here. Now what's he do? He changes course to 200 degrees and travels 2 miles. All right, so now I'm going to set up another little compass right here, because this is where he is now. If he went due north, that would be 0. If he went due east, that would be 90. South would be 180. He's going 200 degrees. So does it make sense to you that this is 200 degrees? Remember, you start measuring up here. 0 up here. 90, 180. Does that make sense that that would be about 200? And I made that little ray or that little vector thing there, I made that short because how long is that one? How far did he travel on that course? 2 miles. So I'll label that 2, and there's a picture of his course. Okay? Now, in this chapter, believe it or not, we will learn how to send a rescue airplane from here to here. Let's say the guy did all this sailing and he started sinking right here. And we need to send a rescue out. We're going to find that magnitude or that distance in that direction to save those people. It's all quite cool. But right now, we're just drawing a picture of it. Okay, that look all right? All right, now I need you to get your purple sheets out. Remember, we are memorizing our purple sheets, and this is what we're memorizing. So get them out. Find the value of all 6 trig functions for theta. Now, my assumption is that you have spent time with your sheet, purple sheet, so you know when it says find all 6 trig functions, we're finding the sine and the cosine and the tangent, the cosecant, the secant, and the cotangent. Now all this is on the purple sheet. Those are called the 6 trigonometric functions. Okay? Here is your right triangle. Here is theta, the angle. Now, with regard to this angle, this is called the opposite side because it is the side across from the angle. This side is called the adjacent side because it is right next to the angle. And this side, of course, is called the hypotenuse. You know what that means, the hypotenuse of the right triangle. Opposite and adjacent are going to depend on the angle you're looking at. So make sure that you focus in on your angle and then label opposite and adjacent based on that. Because if this were theta, then this would be opposite. Does that make sense to you? You've got to pay attention to your angle. That's how you determine opposite and adjacent. Hypotenuse will be hypotenuse. It is always the side across from the 90, the long side. But the other two depend on your angle. Okay? Now, I gotta fill in these. These are all gonna be fractions. So, I'm gonna remember SOHCAHTOA. I don't have to remember that, but it sure helps me. Chief SOHCAHTOA, chief of the trigonometry tribe. S, C, and T stand for sine, cosine, and tangent. O stands for opposite. A stands for adjacent. And H stands for hypotenuse. So if you can label your triangle, you're done. I mean, this is easy. Sine is opposite over hypotenuse. So opposite over hypotenuse would be 2 over root 13. Now, am I allowed to have a radical in my denominator? Nope. So I'm going to multiply the top and the bottom by root 13. So this is 2 root 13 over 13. So this is going to be my final answer. These guys are almost always going to have radicals, so you're almost always going to have to do some of this. All right, cosine. Cosine is adjacent over hypotenuse. So that'll be 3 over root 13. And then won't I do the same thing? So I'm going to end up with 3 root 13 over 13 as my final answer. And then what about tangent? Tangent is opposite over adjacent, so that will simply be 2/3. All right, you all good so far? Okay, now, the other 3 are the reciprocals of the main 3. Sine, cosine, and tangent are the main ones. They're the ones on your calculator. You got a button for sine, cosine, and tangent. You don't have buttons for these guys. These guys are the reciprocals of these. So what does reciprocal mean? Just flip it over, right? Flip it over. Now, I would recommend that when you flip this over, do it from step 1, not from your final answer. Now look at that, guys, and see if you can figure out why. If I flip it from step 1, I'm going to get root 13 over 2. Is there anything wrong with that? No, that's perfect. What if I flip it here, though? I'm going to have a radical in the denominator, and I'm going to have to mess with that. So these are the same thing. This one's just considered simplified. So I'm going to flip it at this point, root 13 over 2. And same thing here. The secant is the reciprocal of the cosine. So that's going to be root 13 over 3. And then the cotangent is the reciprocal of the tangent. So it is 3/2. Trigonometry is incredibly simple, but there is so much to remember. So you got to figure out opposite and adjacent. You got to remember SOHCAHTOA, and you got to remember that cosecant's the reciprocal for sine, and so on. There's just a lot to remember. All right, let's try the next one. This one does not have any radicals in it, so that's good. We're doing the same thing. We're finding sine, cosine, and tangent. Cosecant, secant, and tangent. All right, so here we go. First of all, label your sides opposite, adjacent, and hypotenuse. 13 is clearly the hypotenuse. Would everybody agree with that? Now, your angle's up here. This side is what? What'd you say, RJ? You're right. It's the opposite side. Because it's across from the angle. This one is right next to the angle, so it is the adjacent. All right, here we go. Fill them in. Sine, according to SOHCAHTOA, sine is opposite over hypotenuse. Did you get 5/13? And cosine is adjacent over hypotenuse. 12/13. And tangent is opposite over adjacent, 5/12. Everybody okay with the main three? All right, now do the reciprocals. Cosecant is the reciprocal of the sine. Cosecant is the reciprocal of the sine. You need to know that. So that's going to be 13/5. Secant's reciprocal of cosine. And cotangent is reciprocal of tangent. Boom, boom, boom. Right? Okay, okay. Let's look at the next one. Uh-oh. What's different about the next one? Well, first of all, you're going to have to write all this on your own. I got tired of writing it. So this is what you're finding. You're finding all of these things. But what else? What else is missing? Hypotenuse. How in the world can we find the hypotenuse? Yoo-hoo! There's some famous theorem. Starts with a P. The Pythagorean Theorem. What does the Pythagorean Theorem say? A squared plus B squared equals C squared. So 1 squared plus 3 squared equals C squared. Remember, C is the hypotenuse in the Pythagorean Theorem. So 1 plus 9 is C squared. C squared is 10, which means C is the square root of 10. Everybody okay with that? Nice. Lake, lurk on top of things. All right, let's label our sides. Now we know that's the hypotenuse. Okay, here's your angle this time. So this, look where it is, it's across from the theta. So this is the opposite. Opposite means across from, adjacent means right next to. So this is adjacent. And now we're ready to go. So sine is opposite over hypotenuse. Now this one has that dumb radical again. So while the answer is 3 over root 10, we need to rationalize that. So we multiply top and bottom by root 10. So we have 3 root 10 over 10. Cosine is 1 over root 10. And tangent is 3 over 1, which is just plain old 3. anybody have a question about those three? Because in a minute, we're going to turn them all over. All right, here we go. Cosecant is reciprocal of sine. Now, when I wrote my answer in the answer blank, that's what I wrote down for sine. But before it was that, it was this, right? So that's what I'm going to flip. I'm going to flip root 10 over 3. Or flip 3 over root 10 and make it root 10 over 3. If you flip this, guys, you will get the right answer, but you're going to have to rationalize it first, and that's going to be a mess. So go ahead and flip it right here, root 10 over 3. Same thing here, root 10 over 1, or just root 10. And this one will be we have one more of those to do. So go ahead and get it set up here. Right, so we need sine, cosine, tangent, cosecant, secant, cotangent. Get that set up. What do we need to do to get this ball rolling here? We need to figure out the missing side, don't we? Are we missing a side? And we need all three of them to do the problem. So we're going to have to find that missing side. This side right here. Now, is it the hypotenuse this time? No, it's one of the legs, right? What we call the legs. So we're still going to use the Pythagorean Theorem. But what's it gonna look like? 2 squared plus b squared or a squared, it doesn't matter, equals 5 squared. Is everybody clear on that? So 4 plus b squared equals 25. I got the square root of 21. Did you? Now, if you got square root of 29, you set it up wrong. You have to make sure when you do the Pythagorean Theorem, this one that's over here by itself is the hypotenuse. All right, now, I have to label opposite adjacent hypotenuse. I know the 5 is the hypotenuse. Here's theta. What's the 2? Adjacent. Perfect. And root 21 then is opposite. All right, fill them in. Fill them in. Let's check them when you're done. Do all 6 of them. Paper. I didn't put this on your memorization sheet, so if you want to go ahead and write that on your memorization sheet, that would be good. That really helps me remember what's what. sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So katoa. You don't need that, you don't have to have that, but that's how I do it. I don't know why I didn't write that down for you. All right, who feels confident in your sine answer? What did you say the sine is, Brennan?
5 root 24.
Okay, I think I see what you did. What is sine? Sine is opposite over hypotenuse. So opposite is root 21, and hypotenuse is 5, and that doesn't need any work. The ones that need work are the ones that have the radical on the bottom, right? So Brennan, does this make sense to you? Now, your answer would be the cosecant, because when I turn this thing over, it's going to be 5 over root 21, which then I'm going to have to multiply top and bottom by root 21. So that would be the cosecant. Here's the sine. All right, who's got a cosine for me? Hugh? 2 over 5. Which automatically means the secant is 5 over 2. Cosine, adjacent over hypotenuse. Adjacent over hypotenuse. Everybody okay? And then who's got a tangent for me? Gio?
Radical 21 over 2.
Exactly, root 21, square root 21 over 2, perfect. Which means the cotangent is 2 over root 21, which needs to be rationalized. So 2 root 21 over 21. Kayla, you paying attention, Angel?
Yeah.
Okay. Everybody good with that? The next one, number 2, looks very, very similar in terms of the questions being asked. We have a picture. Actually, we don't have a picture. And all it tells me is there's the setup I'm going to use when I have to draw my own picture. So when you have to draw your own picture, set up your coordinate axis system and just draw your triangle sitting right on it. When you set it up that way, theta will always be right there at the origin. It gets confusing when you try to draw your triangles other ways. So just always draw it this way if you have to draw your own. If it's already drawn for you, that's okay. But if you have to draw your own, draw it like this and put theta right there. Now, what they told me was that the sine was 2/3. Well, without really doing any work, I automatically know then that the cosecant is 3/2, right? Aren't they reciprocals of each other? Sine and cosecant. But now what? What in the world am I going to do now? Brendan? Oh, listen to him. He says label the triangle. Remember, what's sine? Opposite over hypotenuse. So if I look at my picture, the opposite side is 2 and the hypotenuse is 3. Now I know this is the hypotenuse. Where's the opposite side? This one right here, right? Perfect. Perfect. Now I'm still missing the third side. But that's okay, because I dealt with that before. How do I find the missing third side? Pythagorean Theorem. A squared plus B squared equals C squared. Which one's missing? This one. I'll call it A. You can call it B if you want. Don't call it C. That's C. So A squared plus 2 squared is 3 squared. So A squared plus 4 is 9. Are we managing here, guys? So A squared equals 5, and A equals the square root of 5. Now, can you fill the rest of it in? This was opposite. This was hypotenuse. This is adjacent. What's my cosine? So katoa, adjacent over hypotenuse. What's my cosine? Adjacent over hypotenuse. Root 5 over 3? Nothing wrong with that. Root 5 over 3 is fine. What's my tangent? Opposite over adjacent. 2 over root 5. Okay, well that's not so good. So we'll multiply top and bottom by root 5. And we get 2 root 5 over 5. Secant is reciprocal of cosine, so it's going to be 3 over root 5, which needs fixed. 3 root 5 over 5. And then cotangent is reciprocal of tangent, so I'm going to flip it right here and make it root 5 over 2. Problem B, is it close to what we just did? All right, so see how far you can get with it. Do what we did and see if you can get a good start or even a finish on this problem. Kendrick, paying attention? Who has done something? Who's done something? Jacob? Tangent's 4. Kids, that's a gimme. That's an automatic. You know, or you need to know, you're supposed to know from your purple sheet, that tangent and cotangent are reciprocals. So if the cotan is 1/4, then the tangent's going to be 4 over 1. Right? Okay, who's done something else? That's perfect. Guaranteed points right there. Easy. Who's done something else? Brennan?
I think I'm correct. Adjacent is 1 and opposite is 4.
Perfect. Because Brennan is remembering that tangent is opposite over adjacent. So cotangent, the reciprocal, would be adjacent over opposite. So in his picture, this is the adjacent side, and this is the opposite side, because that's theta. So 1, 4. Beautiful. Kids, if you can do that, you are home free, because what's the only other thing left? Find the hypotenuse. And how do we find the hypotenuse? Pythagorean Theorem. Now be careful, what are we looking for? The hypotenuse. So a squared plus b squared equals c squared. So 1 plus 16 equals c squared. For your hypotenuse, did you get the square root of 17? And now we just fill them in. Opposite over hypotenuse. Adjacent over hypotenuse. Flip them over. And clean up anything that needs cleaned up. So these guys need cleaned up. So 4 root 17 over 17, root 17 over 17. And there we go. Remember, anything over 1 is just itself. So I would mark that wrong, but normally we would just write that root 17. Easy. Everybody agree that's pretty darn easy? All right, we're going to do one more. We're going to do letter C. Letter C. Now we gotta make sure, guys, that we understand with theta being right here, which is where you're gonna always put it at the origin. With theta being right there, this is opposite and this is adjacent. Is everybody okay with that? Okay, that's important. All right, what do we know? We know the cosine is square root of 5 over 3. So what does that mean? Cosine. Adjacent is square root of 5, and hypotenuse is 3. So adjacent is square root of 5, and hypotenuse is 3. Now how are we going to find the opposite side? Pythagorean Theorem, and that's the hypotenuse. So we're going to say root 5 squared plus b squared equals 3 squared. Everybody okay with that? What's the square root of 5? 5, yep, good. Not going to be confused by that. So b squared equals 4. Did you get 2? B is 2? All right, here we go. What sign? Opposite over hypotenuse, which in our setup will be 2 over 3. What's tangent? 2, it starts out as 2 over root 5, right? Opposite over adjacent. I'm going to have to fix that. Now I'm going to do some flipping. So I got 3 halves, 3 over root 5, and root 5 over 2. Now which ones need fixed? tangent and secant. So 2 root 5 over 5 and 3 root 5 over 5 are our answers. These are our final answers here. Everybody okay with that? Now, as luck would have it, problem D is exactly the same as B, so we're not going to do it. It is exactly the same. Numbers are the same, so we're not going to do it. And we'll pick up with number 3. Yeah. Remember that your first homework is due on Friday, but you're welcome to turn it in earlier.